Okay, so in this problem, we're asked to calculate the force on charge 1 due to charges 2 and 3. And we're told that the magnitude of charge Q2, positive charge, is equal to the magnitude of Q3, another positive charge. So Coulomb's law tells us about the force of charge A on charge B, which is equal to K times the product of the two charges divided by R squared, where R is the distance between the two charges. So on our picture here, charge Q2 is closer to Q1 than Q3 is. So that means that the force of charge 2 on 1 is going to be greater than the force of charge 3 on 1, which is why I've drawn the force vector for 2 on 1 with a greater length than this one. So to find the total force, we have to find the forces from each charge first. So let's find the magnitude of F2 on 1 first. So that's going to be K times Q2, Q1, divided by the distance between them. And the distance between them is just D2. So that's D2 squared. Now the magnitude of F3 on 1 is again K times Q3, Q1 over D3 squared. So D3 is this total length here. So this is a magnitude. So now we want to know the total force, and force is a vector. So we've got to figure out these components. So this is, I'm going to call this my x direction and this my y direction. So the total force in the y direction is going to be F2 on 1, because F2 on 1 is only in the y direction. So that's just going to be this whole thing here. So that's going to be K, Q2, Q1 over D2 squared plus the component of F3 on 1 in the y direction, which is just going to be F3 on 1 sine theta. So F3 on 1 is K, Q3, Q1 over D3 squared times, we just want the y component, so it's just this component, sine theta. And in the x direction, there's no component of F2 on 1 in the x direction. So it's just the x component of F3 on 1, which is just going to be K, Q3, Q1 over D3 squared times cosine theta. And that's it.